The story of the Ariane rocket is an epic saga, a space odyssey which has seen the Europeans come together, engage and innovate in order to muscle in on the space race.
I'm passionate about space. It's a dream job to get involved in. There's science, research, industry and technology, and you get the chance to surpass yourself. It's an incredible feeling for everybody.
Men and women from the four corners of Europe have succeeded in mastering the technologies enabling them to create some of the world's most reliable rockets.
This technology pushes all boundaries.
If you're in the space business, you are going to encounter failures at a rate far higher than any other human endeavor.
I mean, you cannot be a space power without your own and full-fledged autonomous access to space.
The Europeans united to create a rocket to meet all needs. It's been used for the last 40 years by every country that has wanted to launch satellites into space.
Space is absolutely essential for our everyday lives, for the observation of the Earth, for science, defence, communications. You just can't not go.
But today, unexpected competition from the likes of SpaceX are a threat to European space ambitions. The survival of the whole Ariane adventure is once again at stake.
Ariane 5 has no chance. There's really no way for that vehicle to compete with Falcon 9 and Falcon Heavy.
We urgently needed a new rocket as soon as possible.
Who is going to win the space battle? We're going to look at the choices, the inventions and the dreams which have fashioned the Ariane saga and prepared the launch of the future Ariane 6. In a faraway land on the edge of the Amazon basin, the launch of Ariane 5, the latest European space rocket, is being prepared. This rocket is also known as a heavy launch vehicle, as its role is to send satellites into orbit around the Earth. At the Guyana Space Center in Kourou, everyone is fully focused on the job in hand, serving in an extremely intricate and complex operation. Liftoff is imminent. Japanese and Korean clients of Ariane Flight 252 have come to witness their satellites being sent into orbit. Luz Fabreguet, Ariane Espace's executive director for missions, is trying to help everyone relax.
The most important of today, the two babies on board, the two passengers. We are going to use Ariane 5, our heavy launch vehicle that is mostly used for geostationary orbit.
But the pressure is mounting along with the stakes. Today, the result of thousands of hours of work and hundreds of millions of euros is being played out. For this new mission, two ultra-sophisticated satellites have to be placed into orbit 36,000 kilometers from the Earth, each on extremely precise trajectories. The first payload to be jettisoned is a Japanese telecom satellite called JCSat-17, weighing almost 6 tons. The other satellite is Korean, weighing 3 tons, and once in position, will carry out scientific studies of the oceans, assuming that is all goes to plan. Ariane flight number 252 is another success. In 40 years, Ariane has placed over 300 satellites in space. At the end of 2020, Ariane 5 became the world's most reliable launcher, with 91 consecutive successful launches. For the Europeans, who were the last to enter the space race, this success was surprisingly snatched from the hands of NASA, their eternal rival, at the end of an epic battle.
If you view it as a competition, which I'm sure they did, then you don't abandon the competition just because you're behind. You also recognize the story of the tortoise and the hare. Russia and the United States jumped out early in the so-called space race, but there was always room for people who were going to continue moving on toward the finish line at whatever pace. So I admire them for those decisions.
Europe did indeed start later. But I have to admit that it has more than caught up. We can be very proud of what Europe has done over the last 50 years.
And the race is not over. A new version of the European rocket, a more powerful and also more modular one, is under construction in order to meet the challenges of new space and enable Europe to stay as leader thanks to its groundbreaking reliability. The arrival of Ariane 6 is a turning point for Europe, but Ariane's success couldn't always be taken for granted. Everything began in South America, in Kourou, French Guiana to be more precise, where a new space center had to be built in the heart of the jungle. Within barely 2 years, a 660 square kilometre spaceport emerged from the tropical forest.
The European spaceport in French Guiana is a very well-chosen location because it's so near the equator. So almost all useful orbits are easily accessible to them. It's a great location to have a spaceport.
If even the Americans envied the French for the Kourou Center, it was because it gave the rockets a small boost called the slingshot effect. This was a key factor when the main objective, as it was for the Europeans, was to launch payloads into geostationary orbit. When a satellite reaches an orbit of 36,000 kilometers from the Earth, it can then cover one region of the planet at all times. This is perfect for telecommunications. Only 3 satellites are needed to cover the whole of the planet. Attaining this distant orbit requires a great deal of energy for the rocket launching the satellite. But the speed at which the Earth spins can be used like a sling to fire an object into orbit. And this effect is the most powerful on the equator.
Between Kourou, which is at 5 degrees latitude north, and Florida, which is at 28 degrees, there's a 10% improvement in performance, and a 50% improvement with Baikonur, which is at 51 degrees.
But what could be done with this optimum site when they possess no quality launchers? In 1969, when Neil Armstrong stepped onto the moon, the Europeans were totally disillusioned. They were so far behind. Would it not have been better to just give up?
Firstly, most politicians didn't think we'd succeed. What's more, the decision processes to organize European cooperation seemed very complicated, and everyone was a bit desperate, including me, I have to say. Was it going to be possible for a European program to succeed under these conditions?
In order to start building a powerful launcher, the Europeans were lacking a key item, a rocket engine. A highly powerful element, extremely difficult to put together. The pioneers in this area had been the Nazis 30 years before with their fearful V-2 missile program. The German engineer Werner von Braun and his teams, recruited after the war by the US, were the first to master the techniques of exceeding the speed of sound and reaching space. France, on the other hand, after the war, enrolled a different engineer, Karl-Heinz Bringer, along with around 30 of his team. They were set up in the forest of Vernon in Normandy on a secret site, the Ballistic and Aerodynamic Research Laboratory. Most French rocket engines were designed in this lab.
An engine is really an extremely complex thing, so high levels of skills and experience are required. You can almost say that you have to have blown up a certain number of engines to understand finally how not to have any blow up.
But in a rocket engine, we're pushing the different materials to their limits, with various contradictory effects to deal with. In a combustion chamber, on one side there are gases which reach 3,000 degrees, and on the other side, there are liquids, which can be between minus 200 or 100 degrees centigrade.
There are extraordinary gradients of temperature, all functioning at 3,000 revs a minute and for several minutes. And it can't function more than that, more than a dozen or so minutes. Because there comes a moment when the pressure on the materials is so great that they can't hold any longer. So this technology pushes everything to the limit. An ordinary engineer wouldn't even want to start looking for solutions because it seems totally impossible. But you have to believe in the impossible.
First of all, a rocket has to be a vehicle capable of thrusting off from the Earth, escaping the pull of gravity. But more importantly, it's a vehicle that must accelerate very quickly to attain a critical speed of more than 28,000 kilometers per hour, which is called orbital velocity. This is the first challenge. Then, in order to attain geostationary orbit, acceleration must increase further to reach a speed of 36,700 kilometers per hour.
Acceleration is very important. To go from zero speed, or at least from the speed of the Earth's rotation, all the way to 10 kilometers per second, that's where the energy goes, and that's why we have rocket engines.
To produce the necessary acceleration, the geo-hydrogen oxygen is the most proficient. Used at extreme temperatures, several hundred degrees below zero, it's hard to work with, but extremely efficient. This was the strategic choice made by the Europeans.
We're very good in Europe at cryotechnical propulsion, that is, with hydrogen and oxygen. We have the most proficient engines in the world. The Russians and Americans are better at kerosene-based propulsion.
To be autonomous in space, the rocket had to be able to carry all the propellant supply needed for the engines. This is what dictates what rockets look like generally and why their tanks are so big. You only have to look at the gigantic tanks created for the future NASA's new giant, the SLS. The Space Launch System is being designed for the future explorations on the Moon and Mars. At a height of 120 meters, twice the size of Ariane, the SLS will be the biggest launch vehicle in history.
Basically, when you look at a launcher from the outside, it's a set of tanks, huge drums filled with propellant, which differentiates it from fuel tankers because launchers use up the propellant as they travel. It's as if a fuel tanker uses what it stores to run its engine, but a fuel tanker has a trailer behind it, and the equivalent of this are the stages of a launch rocket. And once the trailers are empty, they're jettisoned. The rocket is then lighter and can go faster.
At the time of liftoff, our space trucks have all their trailers attached. Rockets are considerably weighty. For example, Ariane 5 has a mass of around 800 tons on liftoff. This is the equivalent of about 20 articulated trucks. To enable Ariane 5 to lift off and accelerate as planned, these 800 tons will have to exceed 7 times the speed of sound in less than 2 minutes. With such breathtaking acceleration and dizzying speed, it's easy to see how difficult it is to deliver successful Earth orbit. The engines which enable such extreme challenges to be met are at the heart of the space race. And to prepare the future, the new generation of Arianes will have to be propelled by marvels of technology, which have been thoroughly reworked and reinvented by the rocket engine experts who still operate in Normandy today.
The engine itself, just under 4 meters long, is similar, I'd say, to a section of a nuclear plant. Its ultimate goal is power. It's the Formula One of space. In a way, it's a bit of a shame to have a Formula One engine that only thrusts for 600 seconds, but that's what it's made for.
As well as this new engine which Ariane 6 is built around, another smaller engine called Vinci and designed for the upper stage has a unique characteristic. It's reignitable.
So it's going to change many, many things. We'll be able to carry out extremely complex missions. We can put a first satellite into orbit, then reignite the Vinci engine and put another satellite into another orbit. And above all, we'll be able to ignite the Vinci again, enabling us to completely deorbit the upper stage. This means that the upper stage won't stay in operational orbit. It won't pollute space. So it's a crucial aspect, and it's the Vinci that enables us to do that.
This new European engine, reignitable in orbit, will make Ariane 6 perform at a previously unseen level. It highlights just how much the history of space exploration is based above all on inventiveness and the mastery of these fiendishly complex engines. Meeting these technical challenges has always been an adventure, whatever the era. This was certainly the case in the mid-60s, well over 50 years ago, when the Americans outclassed the rest of the world with their giant Saturn V engines inside the mythical rockets of the Apollo program.
An American flag is left behind on the moon. Because there is no wind or rain on the moon, these footprints will remain for centuries.
After the triumph of Apollo 11, the Europeans, bogged down with the failures of the Europa rockets, were more and more drawn to the Americans, who harped on about the fact that it made no sense for Europeans to go it alone in space. The American stance nearly won the day, until they committed the sin of pride, which was to have serious consequences. Since 1963, France and West Germany had been working together to produce the first geostationary telecommunication satellites. The project came to fruition with the Symphonie A satellite. Not having their own launch vehicle, the Europeans turned towards the US.
When we asked our American counterparts if they would send Symphonie into orbit, explaining that we might be using it for commercial reasons, they refused to do it unless we abandoned its commercial use.
Space was already at the time a business opportunity. And so why would the Americans have launched a telecommunications satellite for the French and the Germans when they themselves had telecom satellites that they were ready to rent out to European users?
At the time, telecommunications were organized at an international level. There was a United Nations of Telecoms called Intelsat, a worldwide organization of which the Americans were in a majority. And so they said to the French and Germans, there is no way you're going to be in competition with Intelsat. Nowadays, every country has its own satellites, but not back then.
In December 1974, the Americans imposed their conditions. Their launch vehicle would lift off from Cape Kennedy with Symphonie A in its payload. The first European geostationary telecommunications satellite was successfully put into orbit by the US. Most of the leading actors in the European space program saw this as a trauma that is hard to relive.
This is a denial of access to a new dimension which could not be accepted by anybody. I think that the chapter of Symphony accelerated the European will. But the will was there. I mean, you cannot be a space power without your own and full-fledged autonomous access to space.
The European Space Group was just a pale shadow of itself when the Brussels Conference of 1973 adopted at the last moment the European rocket project, named L3S, by bringing the English, German, Italian, Spanish, Dutch and Danish on board. And with this momentum, they set up ESA, the European equivalent of NASA. But ESA's big brand new project, the L3S, had a far from exciting name. Names such as Vega or Stella were suggested, but these were also names of German or Belgian beers, so in the end, Ariane was chosen.
Le lanceur Ariane est constitué de 3 étages, d'une case à équipement et d'une coiffe.
With Ariane, the Europeans began to have faith again. A place in the space race was within their grasp. Around 100 engineers were set the challenge of catching up with the Americans. This time, there was a governing body in charge. Frédéric Dall'Est, like Roger Vignel and Yves Sillard, and a handful of talented engineers led the way, imposed a common set of rules and industrial procedures. The European space dream had at last come true. On December the 15th, 1979, 10 years after the failure of Europa 1, the first Ariane rocket pointed skywards. The last chance European rocket, whose first flight, the L01, was about to take place.
There was what is called in the jargon an abort. In other words, the engines were ignited, but there was some abnormal sensor information, and the power was cut.
The countdown started up again 10 days later as an early Christmas present. This time, Ariane 1 lifted off with the full power of its Viking engines, and all settings were green-lighted. Even though the creators of Ariane trusted in their know-how, they couldn't have predicted the success that would follow.
We didn't think that the Ariane program would be on such a scale. We were confident that we would be able to make the grade because we were very ambitious, but we weren't sure of being able to match those ambitions.
They were even less sure because no sooner had Ariane 1 left the ground when it had to face the harsh reality of being in the satellite market. It was still a fledgling sector, but a fast-growing one. To make its mark, the inexperienced Ariane needed to find not just the right technical strategies, but commercial ones to avoid being just seen as a shooting star. To attract clients, a privately owned commercial company was set up called Ariane Espace, a world first. Unnoticed by the Americans, things developed very quickly after that. In barely 5 years, this unusual consortium succeeded in grabbing almost 80% of the world's commercial satellite market.
Honestly, I don't think too many people in the United States paid very much attention to it. The launch business, the space launch business, is a very hard business. It's very demanding. The failure rates are very high for the first tranche of any new launch vehicle. And so I don't believe a lot of people took them seriously. But they kept to their task, and as the years went on, they became a very reliable vehicle, and really by the 1990s, they were launching the lion's share of the world's commercial payloads.
But to stay in the race, the launchers were afforded no respite. Ariane 1 needed to transform without delay. This is what gave the stimulus to the birth of a series and rapidly produced siblings for Ariane 1, Ariane 2, 3 and 4.
The adjustments with Ariane 3 and 2 were fairly straightforward. Ariane 3 actually flew before Ariane 2. As derivatives, they were similar to Ariane 1, but the real masterstroke was Ariane 4.
For Arianespace, the fourth incarnation of Ariane was a real success. With its different combinations of strap-on boosters with variable power, it was a versatile launcher, adaptable to all customers whose satellites were getting bigger year by year. Even if Ariane 4 became the standard rocket for satellite constructors, its position was still fragile. Competitors were hot on its heels. Something was missing which would enable it to become a durable leader. It was too expensive.
When we created Arianespace, we were faced with a serious dilemma. American industry benefited from government orders which were extremely lucrative, into billions of dollars. This wasn't the case in Europe. We weren't managing to be competitive. So I came up with the idea, despite a good deal of reticence, because it would be tough, of launching 2 commercial satellites simultaneously. This would help share the fixed production costs of the launch vehicles and the construction sites more efficiently.
The Europeans set out to meet this challenge in the spring of 1978. They thought up the Silda, a dual launch system. Another outrageous gamble.
How could 2 satellites be launched at the same time? It wasn't simple. That's why a cup-shaped support structure was invented. So one of these satellites was housed inside it, with the other one mounted above it. The problem was that once in orbit, the 2 satellites had to be separated. So we had to come up with a system of detaching the structure. Firstly, satellite number 1 was jettisoned. Then the cup-shaped carrying system was jettisoned, ensuring that it didn't collide with the first satellite that had just been released. And then, after a short while, the second satellite was jettisoned. It was a world first and it worked perfectly. It's been constantly developed since and has become a standard. It's still working today on Ariane 5 and soon on Ariane 6.
And so Ariane 1 and its siblings became the world's leading satellite launchers. Unexpectedly, they managed to shape the sector to such an extent that today Ariane is indispensable, even within the country of space exploration. Nevertheless, each new contract has to be fought for. Every year in Washington, Arianespace sets up its stall at the Satellite Trade Fair, the world's huge commercial space market. For those who want to stay in the race, it cannot be avoided. To take advantage of the gathering of all these major players in the space business, the small Arianespace team operates in commando mode to organize as many meetings and strategic sessions with the satellite operators as possible.
The timing and the deadlines are what's important, because otherwise it'll cost them $4 billion.
Here, the stakes go beyond simple commercial dealings. The whole Ariane adventure depends directly on these contracts being signed. In a discreet cafe, away from any onlookers from the sector, a hushed discussion is taking place about a huge satellite launch contract. Listening carefully, it's possible to grasp the name of the competitor Ariane is up against.
are you sure that at the end of the day you must launch with us in 2022, not in 2023, just to better understand your constraints in the choice you are going to make between SpaceX and ourselves?
The name is out, SpaceX. It's on everyone's lips and focuses everyone's mind. It's the new aggressive competitor, which has shaken up the world's space business and has put Ariane under pressure. Over the last few years, competition in the space race has radically changed. In the same way that the US didn't see Ariane coming, Europe didn't anticipate the new generation emerging from the digital revolution in Silicon Valley.
Things were happening in California with Elon Musk and SpaceX, who were able to offer cheaper, upgradable launchers, even if they weren't yet talking about them being reusable. But these soft signals from California were not taken seriously enough. The mindset at the time was that it wasn't going to be a digital startup, which knew nothing about the space business, that would revolutionize a sector that was built on science, research, and industry.
And yet, in the space of a decade, startups from the digital revolution forced their way with their nonconformism onto the scene, to the point of cultivating, in the case of Elon Musk, founder of SpaceX, a rock star personality, something that had never been seen before in the very controlled environment of the space industry. And he didn't intend to just have a walk-on part. February 2018, SpaceX went ahead with the inaugural launch of Falcon Heavy, a monster of high technology, which marked the return of the US to the center stage of space conquest. And the rest of the world looked on astonished as each stage of the rocket returned to Earth. Or sea. The alarm bells were ringing. SpaceX seemed to have come from nowhere, with new launch vehicles built in record time, brilliantly highlighting the emergence of new space. They were almost entirely reusable, targeting both flights with crews as well as satellite launching, offering more or less the same level of performance as Ariane, but at almost half the cost. The fact of the matter is that 10 years before, SpaceX had been an outsider, just as Ariane had been when it began.
Welcome to SpaceX. Here we are in the lobby. It's very white right now, but there are actually some cool elements coming in soon that will make it less white.
We're getting ready to weld together those barrel sections and create our third tank, which would actually be the first flight tank.
Success stories tend to forget the difficulties encountered at the outset. Nevertheless, Elon Musk and his teams had plenty of crashes before being successful with trouble-free orbits. Legend has it that it was on the last attempt, financed by Musk's own personal funds, that his gamble paid off.
If you're in the space business, you are going to encounter failures at a rate far higher than any other human endeavor.
There's nothing worse than fearing failure, because if you do, you refuse to accept progress. I know all the objections. I was director of launchers. We knew all the good reasons for not launching Ariane. But if we didn't launch it, then yes, it was the best way of not failing. But on the other hand, we wouldn't get into space. So you mustn't fear failure. There's no progress without failure.
In 1981, NASA had no qualms in taking enormous risks with a legendary reusable and crewed rocket named the Space Shuttle. Also able to carry satellites in its payload, the shuttle completely shook up the space race, and inevitably, the fate of Ariane. When Columbia, the first shuttle, returned to Earth, landing smoothly like an enormous glider, the whole world was blown away by the feat. All the other existing space programs found themselves obsolete overnight.
When the shuttle came on the scene, we were very impressed. It was a superb contraption. What bothered us was that everyone around us was saying, "You're carrying on with Ariane 1. You've got an old device when others are going to space wearing their Sunday best. You're totally ridiculous." We heard all sorts of things like that.
The Americans were so confident that they banked everything on the shuttle and abandoned classic launch vehicles. But it was a complex and costly adventure. Only a few launches took place every year, and what was worse, the shuttle turned out to be unstable and fragile.
Challenger now heading down range.
On January the 28th, 1986, an explosion lit up the Florida sky. The Challenger's space shuttle broke up, and its crew perished with it. It was an unforgettable, traumatic event in the history of both American and world space exploration.
It was not a wise move to have only a single launch capability. I mean, as great as the shuttle was, it could fail too. And then if you have nothing else, you have nothing else. So I think the Europeans, they realized that there would still be a role for expendable launch vehicles, even though the US was building and deploying the space shuttle. And they turned out to be right.
This historical turning point had a certain irony. The misfortunes of the space shuttle cleared the horizon for Ariane.
6, 5, 4, 3, 2, 1.
Ariane stepped into the breach. These were the golden years.
I was lucky to be president of Ariane Espace during the period when Ariane was #1. When we got together for conferences in the US, the Americans would say to me, "You're a magician," because they were stunned that all the American satellites were being carried by Ariane and that there were no alternatives in the US at the time.
Confirming this impressive momentum, Ariane 5 finished its development phase and took over from Ariane 4. It was a new, imposing Ariane, which could carry payloads of 6 tons into geostationary orbit, twice as much as Ariane 4.
Attention pour décompte final. 5, 4, 3, 2, unité, feu.
After only 37 seconds, Ariane 5's first flight, the V501, turned into a disaster. A computer software malfunction instructed an abrupt change of direction. It was an unnecessary and erroneous adjustment and caused the launcher to self-destruct. Stupefaction all around. A failed first flight can mean the collapse of a whole program because nothing has been fully tested. Doubt spreads. Politicians get annoyed, heads roll. After Flight 501, Ariane nearly died.
The following 18 months were really difficult. Obviously, we understood straight away what had happened and how to rectify it. But we said, if that can happen, then so can that. So we checked everything again from A to Z. And therefore, 502 went really well. Second flight in September 97.
After the successful flight, the new European rocket got back in the air with panache. Firstly, with a test launch of a capsule. Then by multiplying satellite missions with ever bigger loads and a variety of orbits. It even managed the feat of launching the Rosetta probe, which landed its module Philae 10 years later on the Chury comet. Confidence had returned, and the engineers wanted to go even further. On December the 11th, 2002, the first Ariane 5 capable of carrying a payload of 10 tons, the Ariane 5 ECA, was due to be launched. At the time, it was the world's most powerful rocket. On board, it carried 2 huge French telecom satellites with a value of 630 million euros.
We had slowly but surely got Ariane 5 ready to fly again and gain confidence. We were beginning to consolidate its position in the commercial market. We had a good list of orders. Ariane 5 ECA was on its way and the outlook was good. And then, failure.
23h21 heure de Paris hier soir. Suite à une anomalie dans le circuit de refroidissement, une forte perturbation agite le moteur Vulcain. 7 minutes et 35 secondes après son décollage, les responsables du centre guyanais de Kourou décident la destruction du lanceur, provoquant la perte des 2 satellites qu'il transporte.
On behalf of Ariane Espace and all our partners, I would like to apologize to our customers, Eutelsat and the CNES. As you well know, this can be a tough business, and moments like these are a cruel reminder of this.
Europe could not afford to lose Ariane. Everyone within the teams dug in deeply to help them break the bad run. Towards the end of 2003, after many months of hard work, the new super powerful Ariane 5 successfully returned to the launch pad. The juvenile errors had been corrected. Ariane 5 was a star born out of suffering. Pain that was etched into the minds with long-term side effects. For the first time in its history, rather than repeat its successful policy of trying to get a step ahead, Ariane rested on its laurels.
It took a long time to get a consensus in Europe to enable us to develop a new Ariane 6 program. The risks had been so high, and the decision makers had taken them so badly, that we just didn't want to let the engineers destroy everything in the quest for a new adventure.
Even when you win, it's not for all time. There's not a finish line. You have to keep running, you have to keep innovating, you have to keep improving. If you don't keep running, other people are going to pass you.
The trauma of the chaotic early days of Ariane 5 paralyzed European innovation. As for the satellite market, it became ever more diverse, developing in opposite directions. On the one hand, small, light, ultra-modern satellites emerged, electrically propelled. But so did a great number of even smaller satellites, such as the European Galileo navigation system, launched in constellations. And then there are the geostationary telecom satellites, which are still around and not getting any smaller. Responding to this wide variety of missions with a single heavy launch vehicle like Ariane 5 has become impossible.
Ariane 5 has no chance. I mean, really, I don't say that with a sense of bravado, but there's really no way for that vehicle to compete with Falcon 9 and Falcon Heavy. So if I were in the position of Ariane, I would really push for an Ariane 6. I think that's the right move. The next version of Falcon 9 is actually able to go to a lower price. So if Ariane can't compete with the current Falcon 9, it sure as hell can't compete with the next one.
To face up to Elon Musk, everything had to be changed and reinvented. Ariane had no choice but to remodel, lock, stock and barrel.
We looked at the basic problem that needed resolving. We wanted to be twice as cheap while being high-performing and more flexible. So it was a case of what can be made with this amount of money, and we turned the issue around, and we were able to reconcile space and major industry, which produces on a large scale, but which doesn't have the same issues of reliability that we have. Because when a car breaks down, you just call the repair service. It's a bit more difficult when a plane breaks down, but it can generally turn around and land. But for a rocket, the slightest spare part can cause it to fail and put it out of commission, along with the payload, which costs hundreds of millions of euros. So the message I tried to get across was that cheaper meant more reliable, because cheaper means easier to make. When it's easier to make, it's more ergonomic. It can be put together more easily. There are fewer mistakes.
Along with the new factory in Les Mureaux, west of Paris, 13 other European sites are part of the industrial transformation of Ariane. One such site is in Bremen, in northern Germany, where just like in France, a younger generation of engineers are at the helm of this technological renaissance.
When you work in this building and have daily contact with the materials here, you can see the progress. We can see with our own eyes the first upper stage of Ariane 6 taking shape. The idea is to take innovations and procedures from the high-tech automobile industry and apply them to the astronautic sector. One of the biggest changes is working entirely digitally. We use tablets in the integration process, and all the information for the finishing stages is at our fingertips, without needing to resort to paper. These are just some of the principles borrowed from Industry 4.0 that we're trying to put into operation in the production of Ariane.
Ariane 6 is a rocket born out of the digital revolution. This has enabled the quickest production time in the history of Ariane. The teams are working in parallel on the design of a new revolutionary engine named Prometheus, which will be constructed chiefly from 3D metal printing and above all will be reusable. The new engine is an urgent priority, which will enable Ariane 6 to arrive as quickly as possible in the marketplace. In short, Ariane 6 is like an industrial Ariane 5, but as modular as the mythical Ariane 4. Less than 7 years after the first designs, Ariane 6 is already in production. 2020 was a key year, and even if Ariane has lost some ground, it is still in the race. Ariane 6 won't be able to keep its promises unless it possesses an infrastructure at least as modern as that of SpaceX. This is why the Kourou spaceport has been hosting over the last 5 years a gigantic new construction site, the scene of the 4th Ariane launch area. This new complex undoubtedly constitutes the most important break with traditional Ariane practices. The whole assembly process of Ariane has been transformed. As evening arrives, the container ship Toucan arrives in the Kourou River estuary and releases its cargo. This particular evening, the huge casing carrying Ariane 5 has something else alongside it. Following it on its journey into space is a strange white rocket segment.
It's a model of the booster that will be attached to Ariane 6. There'll be 4 models like this to represent the 4 boosters. There's also a model of the central stage and one of the upper stages where the satellites are housed. This enables us to modelize the launcher. We're doing this to test out the Ariane 6 assembly line here in Kourou, to check that everything is put together correctly and optimized. But more than that, of course, to show that when we take delivery of the real Ariane 6 elements, we're able to deal with them and to put them together without damaging them.
The first models of the boosters are already in place. A steel frame also enables the central stage of the future rocket to be simulated. Ariane's industrial mutation has also brought about a revolutionary transformation in its final assembly and its launch pad. Whereas before, the launchers were assembled vertically and very slowly transported to the launch pad, from now on for Ariane 6, both the preparation and the journey will take place horizontally. It's only when the rocket is at the foot of the launch mount that it'll be moved into a vertical position. The 90-metre-high service structure will roll away on tracks. "7,000 tons, the equivalent of the Eiffel Tower's metal structure, will be moved away to safety. This procedure has been entirely rethought and will halve both the length and the cost of the launch. In fact, as well as the new launch pad, the whole Kourou spaceport has been transformed to accommodate the new Ariane, and along with it, prepare the next stage in the battle of the space race.
We're more independent now than we've ever been, which gives us the freedom to achieve our dreams and take our place in space exploration.
What Europe has achieved in space is a demonstration that Europe works in space.
I think it's vital to invest in space in a serious way. Investing in space is investing in the future.
Ariane has come a long way in 40 years. Year after year, the European space dream has become reality thanks to the series of Ariane rockets. These incredible machines, pushed to unimaginable levels, have opened a glorious path for Europe into space and constitute one of the old continent's greatest successes. For Europe to stay in the race, the 6th Ariane will soon be on the launch pad. And it's with this rocket that the Odyssey will continue to be written.